Hello, everyone, and welcome to Chapter 3 Matter and Energy. This is taken from Introductory Chemistry Concepts and Critical Thinking, the 7th edition book of Charles H. Corwin. So, to start our discussion, let me present to you the learning objectives of our discussion for this video. So, we have a lot of objectives to satisfy at the end of this chapter. You should be able to, number one, describe the motion of particles and the effect of temperature on the solid, liquid, and gaseous states of matter. Number three, classify a sample of matter as an element, compound, or mixture. Number four, memorize the names and symbols of 48 common elements. Number five, list the properties of metals and nonmetals. Number six, number 6 and 7, we will predict whether an element is a metal, nonmetal, or semi-metal given its position in the periodic table, and predict whether an element is a solid, a liquid, or gas at 25 degrees Celsius or the room temperature and at normal atmospheric pressure. Number 8 is we will calculate the number of atoms of each element in a compound given a chemical formula. Number 9, we will apply the law of definite composition to a compound. Number 10, we will classify a property of substance is either physical or chemical. We also, number 11, classify a change in a substance as a physical or chemical change. Number 12, we will apply the conservation of mass law to chemical changes. Number 13, we will distinguish the difference between potential and kinetic energy. Number 14 and 15, we will summarize the relationship between temperature and kinetic energy, as well as kinetic energy and its physical state. Number 16 is to apply the conservation of energy law to physical and chemical changes. And lastly, we will identify or we will introduce the different forms of energy, such as chemical, electrical, mechanical, nuclear, heat, and light. So we have a lot of objectives to meet at the end of this lecture video. So we'll start with the physical states of matter. So we will be hitting the first two objectives listed a while ago. So we all know that we are studying chemistry, and when we study chemistry, we are studying matter. But if we will define matter, it is any substance that has mass or occupies volume. If you remember in your elementary days, this is how we define matter. Okay? And we know that matter will exist in one of the three physical states, such as solid, liquid, and gas. So shown here is a picture of water in three different states. So your ice here in the iceberg, that is your solid. Then you have your seawater, so it's in the liquid form, and the water in our atmosphere, so that is your gaseous state of water. Okay, so let's describe our three states of matter one by one, and tingnan natin yung mga properties nila. So when we are talking about solid state or solid, so in a solid, the particles of matter are tightly packed together. As you can see here, this is a diagram. Those greens and brown, these are atoms. So the particles, we'll just call this uh, blue and brown balls as your particles. So as you can see, the particles here are close to each other. They are tightly packed together. And that is the reason why your solids have a definite or fixed shape, because of the tight packing of your particles. Therefore, if you have a definite or a fixed shape of your solid, you cannot compress your solid because it's already tightly packed together. And because of its fixed shape, As you can see, it looks like here a cube. So it has a definite volume. So it has a definite volume. And among the three states of matter, your solids will have the least energy because as you can see here, the the particles are still moving but very small movements only. Okay? So your solids will have a very least energy. Okay? If we will compare it with your liquid state, so somehow in a liquid, the particles of the matter are loosely packed and are free to move past one another. So as you can see here, these blue balls here, these are the representation of your particles. And as you can see, there are they are free to move but with a slight degree of freedom. Okay? We all know that liquids have an indefinite shape. So these liquids will only have a shape if they assume the shape of their container. For example, if you place your reagents or chemicals in a glassware like an Erlenmeyer flask, the the liquid inside it will take the shape of the Erlenmeyer flask. Okay? Third characteristic or property of liquids is it cannot be compressed, just like your solids. But this time, and also this time, your liquids have a definite volume. Okay? So in terms of energy, your liquids have less energy than gases, but more energy than solids. So the liquid state is somehow in the middle. So your solids will be least energy, and then your gases will have the higher or the highest energy. So this is in your liquid state. For gaseous state, as you can see here, the particles of matter are far apart. So these are the representation of your gas particles and are uniformly distributed throughout the container. So as you can see, the particles of your gas are free to move and they somehow bump with each other. Okay? So gases have an indefinite shape and they also assume the shape of their container. For example, if you have a balloon, so the air or the gas inside your balloon, for example, you use helium. So the helium gas inside the balloon will take the shape of their container or this balloon. We have different shapes of balloon, right? So your gases will take that shape. On the other hand, your gases can be compressed. So as you can see here, this is a piston. So imagine there's air inside and you apply force. So in that way, your air inside the piston becomes compressed. And that means your gases have an indefinite volume because of the changes. As you can see here, before the force was applied, before compression was made, it has a bigger volume. But as you can see now that the gas is being compressed, the volume becomes smaller. So that's why we have gases have an indefinite volume. And in terms of energy, your gases have the most energy among the three states of matter. So we translate or pwede natin kasing i-translate yung movement ng particle as energy. So the more movements you make, then that means you have more energy within you. Okay, so that is the definition of your gases have most energy among the three states of matter. See, I mentioned earlier that solids, the particles are very packed together, tightly packed together, so they cannot move. So, nakaka-move sila pero very little movements lang yung nagagawa nila. Okay? So, just um, to summarize yung tatlong physical states of matter natin, we have here a table and the figure. So, in shape, your solid has a fixed shape. Liquids have a variable shape because it takes up the space of takes the shape of your container as well as in gases. Sa volume naman, solids and liquids have fixed volumes, but your gases will be variable. When say variable, this is changing. Okay? In terms of compressibility, if you can make compression sa solid and liquid, hindi nagagawa. It's negligible. But in gases, it is very significant. Again, this is just a representation of the three states of matter, our water. So we have solid. So this is called your I. This is your liquid in your water. And then we have your water vapor as the gaseous state of water. Okay? So that is the three states of matter. In fact, we have different states of matter, but we will focus only with these three states of matter: solid, liquid, and gases. Now, the question is like this: can we change a particular state of matter to another? And the answer is yes. So, we also have changes in this physical state. So according to our slide, most substances can exist as either a solid, a liquid, or a gas. Meaning, at a particular time or a particular a particular time, your substance will exist in one state. But you can also change that to another. For example, we know that water exists as a solid below or at 0 degrees Celsius. That is the freezing. This is the freezing temperature or point of water. So that's the 0 degrees Celsius. That's the freezing temperature. It exists as a liquid between 0 and 100. And then, if it reach 100, so 100 degrees Celsius kasi this is the boiling temperature or boiling point of water. So this time ito na yung ano siya nagiging vapors na siya. Nag-evaporate na siya. So a substance can change physical state as the temperature changes. If you increase the temperature, for example, in the case of water, if the temperature is very low, that's your ice. At normal temperature or normal room temperature, your water exists as a liquid, and at a very high temperature, your gas will become a vapor or steam. So how do we change one state from another? So let's look into the changes between solid to liquid and vice versa. When a solid changes to a liquid, the phase change is called melting. As exemplified here, this is an ice cube that was left maybe in your kitchen. So as time goes by, your ice becomes water and the process is called melting. And melting will occur only if there is an increase in the temperature. So a substance melts as the temperature increases. But how about if we do the reverse? So we have liquid to solid. So when to a solid, the phase is called freezing. So this one is a GIF or animation of the freezing. As you can see, ice crystals are being formed. So this will only happen if your substance, the temperature of your substance decreases. So a substance freezes as the temperature decreases. Okay, so please take note of the terms melting and freezing. If we have naman the change from liquid to gas, so when a liquid changes to a gas, the phase change is called vaporizing or vaporization. Okay, so vaporization. So I'll just write it here. Vaporization. So a substance vaporizes or becomes a vapor as the temperature increases, as shown here. For example, if there's a puddle or a pond, then the sun will heat that portion. So as you can see, it slowly evaporates. So from liquid, it becomes gaseous. So that process is called vaporization. So itong vaporization is the one you also encounter in your water cycle. So that is one process in the water cycle. But if we will do the reverse, so from gas to liquid, so when a gas changes to a liquid, the phase change is called condensing, or we also call it condensation. So for example, this one, sa pag yung ano, um, yung gas dun sa window nyo, ba, unti-unti nagkakaroon ng droplets. So that is called condensation. And condensation only happens if the temperature decreases. So again, the reverse of vaporization. So you should decrease the temperature in order to condense your gas back to liquid. So in our first two slides here, yan, we are able to convert solid to liquid and liquid to gas. But how about, is there a phase change between or involving solid directly to gas or gas to solid? And the answer is yes. So this is a direct phase change. So as you can see here, it will no longer pass through the liquid state. So when a solid changes directly to a gas, the phase change is called sublimation. So yung sublimation happens only if there is an increase in the temperature. Okay? So one example natin yan ay itong dry ice. So dry ice is just carbon dioxide. So this is the one used in concert. So yung parang foggy effect. So from solid, it becomes gas directly. Okay? So this happens only if the temperature is increased. But if you do the reverse or the kabaliktaran niya, the gas, when a gas changes directly to a solid, so meaning gas to solid siya, the phase change is called deposition. So this happens if the substance, the temperature of the substance decreases. So a substance undergoes deposition as the temperature decreases. So an example here naman is your iodine crystal. So iodine, this one, the purple fumes or usok, ayan, as you can see, it's slowly deposited on the surface of this round bottom glass. So from gas, it became solid on the surface of your round bottom glass. Okay? So these are your different phase changes. So to summarize, so you need to increase the temperature if you want to convert your solid to liquid and to eventually to gas. So if you want to go the other way around, so from gas to liquid to solid, you need to decrease the temperature. Again, from solid to liquid, that's melting. Liquid to solid, that's freezing. Then from liquid to gas, it's vaporization. And then from gas to liquid, that is called condensation. For solid directly to gas is called sublimation. And then gas to solid is called your deposition. Okay? So that is how we can convert or change the state of one substance to another by simply changing the temperature. It's either you increase the temperature or you decrease the temperature. Okay? So we're done discussing the three states of matter and the phase changes involving these three states of matter. Now, we will jump to another topic, which is the classification of your matter. So, we will hit here the objective. We will classify a sample of matter as an element or a compound or a mixture. So, matter is divided into two classes. So, we can call it the mixtures and the pure substance. So, when we say mixture, these are composed of one or more substances that can be physically separated into its component mixture. So, ang pwede nyo isipin dito is your salad. For example, salad. There's lettuce, there's tomato, there's um, other ingredients. So, you can simply pick it up and then separate. So, that is physical separation. But if you have a pure substance, these are composed of only one substance and cannot be physically separated. For example, if you have a copper wire, so uh you can no longer separate those particles in your copper wire because it's made up of only one substance. In fact, it is made up of copper, the element copper. Okay, so you cannot do here a physical separation. So if in mixture, you can physically separate this into the component substances, sometimes your pure substances can be separated through chemical means. So if it cannot be physically separated, you may use here chemical separation methods for for a particular type of pure substance. So let's focus more on the mixtures muna. So again, there's another subclassification for mixture. So we have heterogeneous or homogeneous. So what makes it heterogeneous is you will look into the face. You will look at the face. So in heterogeneous mixture, this doesn't have a uniform properties throughout. For example, if you try to mix your if you try to mix your sand and water, they don't mix, 'di ba? Your sand will not dissolve in water. So, if for example, you put a spoonful of sand in your water and you stir it, eventually after some time, your sand will settle and you will see there's a separation of phase. So, the sand is in the bottom of your container and water is above it. So if you can see two phases here, then that is heterogeneous mixture. Okay? So if you can recall our discussion on separation of mixtures, so you just do a decantation. So you just you decant the water, you remove the water or you just throw the water away and you're left with sand. But if you want to be sure that your water will be purely water and no sand particles will will be included in your water, so you do filtration. So I hope you can still remember our discussion on separation of mixture. On the other hand, you have another type of mixture, we call it homogeneous mixture. So in homogeneous mixture, it has a uniform properties throughout. For example, an example here is salt and water. So if you dissolve salt with water, eventually it will dissolve. And if you have now a prepared salt water or salt solution, you can no longer identify nasaan yung salt, nasaan yung water because it's already dissolved. The salt is already dissolved in your water. And you will see here just a one phase. So one phase lang. So if that's the appearance of your mixture, then that is a homogeneous mixture. So again, how do we separate salt and water? You just use evaporation. So you use evaporation technique to separate out the salt and water because you know water will evaporate. diba? And salt will be just left in your, per se, let's say, maiiwan siya doon sa inyong evaporating dish. Okay? So that is for mixtures. How about pure substances? So your pure substances can be further divided into two. So we have a compound and an element. So let's start muna dun sa element because it's easier to describe or to explain. An element cannot be broken down further by chemical reactions. So if you have a copy of your periodic table, those elements, the 118 elements there, these are the simplest na. Yan na. So you cannot break it down further into smaller particles for now. Okay? But if you have a compound, yung compound kasi is a combination of two elements. So for example, water and oxygen. I mean hydrogen and oxygen rather. If you mix hydrogen with oxygen, you will create water. Diba? We know that your water is H2O. So you have two hydrogens, one oxygen. So your hydrogens and oxygen, these are your elements, diba? H and O. So these are elements, pag sila ay nag-combine, you will form the compound water, H2O. Now, if you want to break down the water here, you will use a chemical separation technique. So if you will search na lang, you will use the electrolysis. So in electrolysis, you supply energy. So you use electricity to separate the hydrogen and oxygen from your water. Okay? So that is for pure substances. So just to summarize the things that I have said for mixtures and pure substances, so matter is again divided into two, pure substances and mixtures. So in mixtures, you have heterogeneous and homogeneous. So again, another example for heterogeneous here is your oil and water. So we know that oil and water don't mix, and we have there's a formation of two layers. So oil floats on top of water. For homogeneous naman, we have your salt solution. Yeah, so as you can see here, salts are dissolved in your water, and you can no longer pinpoint which ones are the sodium chloride or the potassium chloride. So the properties are uniform to all throughout the mixture. So that is homogeneous. In say homogeneous, you have one phase. Okay. So for pure substance, you have compounds and elements. So when say compounds, this is a combination of two or more elements bonded together, and you can separate the compounds into elements by using chemical means. So for example, if you want to separate out the hydrogen from the oxygen from your water, you use electrolysis. Okay? So one classic example of our compound is water, and another classic example of element is your gold. Okay? If you want to separate out the mixture into pure substances, then you use here physical means. So I already discussed the different separation of mixtures like filtration, evaporation, decantation, distillation, and so on. So please review your separation of mixtures uh, lecture discussion. Okay? So now na na-discuss natin kasi yung compounds, elements. So, we'll focus now next sa elements. So, we will look into the different names and symbols of elements. And according to our slide, you should memorize, but rather I want you to familiarize yourself with the names of symbols of the common elements. Okay? So, in terms of occurrence kasi, There are over 100 elements. In fact, it's 118 as of the latest count. There are 118 elements that in your periodic table. Pero over 100 elements lang that occur in nature because some of them are lab-made and some are very mabilis lang yung buhay nila or uh, half-life nila. So, pagka-create kasi ng ibang mga elements, they already disintegrate. So, nawawala na agad sila. So, 81 of those elements are stable. But there are 10 elements that account for more than 95% of the mass of the Earth's crust, water, and atmosphere. So, as you can see here, pinakamahalaga dito na element is oxygen because this one is the element na ginagamit natin for breathing. So, second to that is your silicon. So, why silicon? Because silicon Si, this is a component of your rocks. So, silica. So, yung rocks kasi natin is SiO2. So, this is silica. And this is the one responsible for the formation of our rocks. So, di ba? Ang ating classification ng Earth kasi in our planetary definition kasi ay siya ay rocky planet. So, dapat it's made up of rocks. And those rocks are made up of silicon. So, we have also aluminum, iron, calcium, potassium, sodium, magnesium, hydrogen, titanium, and other elements. So that is for the atmosphere, the water, and the crust of the Earth. But in the body naman, again, oxygen is the most common. Uh, in the body, oxygen is the most common element found in your body. So in Earth's crust, it's around 49.5. The human body is 65%. So in terms of the Earth's crust kasi, silicon is the second biggest contributor for the element. Pero in our body, it's carbon. Kasi bakit carbon? We all know that and carbon kasi kapag nag-bond siya with other elements, that can make an organic compound. And we know that human body is made up of organic molecules. So we are organic. Okay? So, paano ba nagkakaroon ng names yung mga elements? So, each element has a unique name. For example, may mga may mga origins kasi yan, yung mga pangalan ng mga elements natin. For example, hydrogen. So, it is derived from Greek word. So, you can separate hydro and then gen. So, di ba, hydro means water. And yung gen kasi is like parang Genesis. So, when you say Genesis, this is the star. So, its name is hydrogen means water former. Kapag naman yung carbon, it's derived from Latin. So, ang pinagmula naman niya is carbo. So, it means coal. Yung scandium naman is named after a place called Scandinavia. So, it's a place in Europe that is presently Iceland, Denmark, Norway, Sweden, and Finland. And there's also some instances that your element is named after a personality or a scientist. Like, for example, curium is named after Marie Curie. So, Marie Curie kasi also discovered elements. So, other elements ay na-discover din. So, ino-honors siya with the naming of an element after her. Okay? So, each element is abbreviated using a chemical symbol and usually these are one or two letters long lang. So, isang letter or dalawa lang siya and dinederive siya yung ating symbol from the name of the element. For example, carbon is C. So, siya lang, letter C, carbon is C. But, for example, there's another element starting with letter C, cadmium. So, ang kanyang symbol ay Cd. So, bakit hindi Ca? Kasi kapag Ca naman, you know this is calcium. So, when a symbol has two letters, the first is capitalized and the second is lowercase. For the example here, yung cadmium, first letter is capitalized and then yung letter D for cadmium is lowercase. So again, another set of derivation, like ito naman, yung mga ibang elements kasi is derived from Latin name. For example, gold is Au from the Latin word aurum. Then, kasi aurum in Latin is gold. Yan. Silver is Ag, argentum. Copper is Cu, cuprum. Mercury is Hg, hydrargyrum. Potassium is K, kalium. Sodium is Na, natrium. Antimony is Sb, stibum. Tin is tannum. Iron is Fe, ferrum. And then zinc is Cn or zinc. Okay? So, dinederive siya from Latin or Greek words. So, ito, may tanong dati, ano ba talaga daw dapat ang spelling ng aluminum? So, meron kasing aluminum and isa ay aluminium. The most common kasi name ng mga elements natin, they end in IUM. Yum. Like pa, purium, uranium. So, IUM. So, kasing element number 13, we call it aluminum. In the US and Canada, pero the rest of the world, they call it aluminium. So, ano ba talaga dapat ang tamang spelling? So, the different spelling is believed to be from a spelling error which caught on the US and Canada. So, ang nag-decide ng talagang official name ng element number 13 natin is the IUPAC. So, the IUPAC here is the International Union for Pure and Applied Chemistry. Applied Chemistry. So, the IUPAC, IUPAC, sabi ng IUPAC ay, the official name is aluminum. So, we still follow the ending IUM. But in 1993 also, yung IUPAC, IUPAC, they also recognize the alternate spelling as aluminum. Pero tayo ang gagamitin talaga natin is aluminium. So, this one is pronounced as aluminium. Okay? Okay. So, I hope that's clear for the symbolism and the naming of your elements. So far, ano pa rin, continuous pa rin yung discovery ng mga scientists na mag-create mag-create ng new elements. So, after 118. So, there are still efforts to create new elements. Now, since na-discuss natin yung elements, we can actually classify elements into three. So we have metals, nonmetals, or semi-metals. Or this one is also called your metalloids. Okay? So the elements can be divided into three classes, your metals, nonmetals, semi-metals, or metalloids. So if you're familiar with your periodic table, we can actually distinguish where are the metals and where are the nonmetals. So in this quick picture here, yung ating metals kasi can be found in the kaliwa. So left side of your periodic table, and then your non-metals will be on the right side. So where are the metalloids? The semi-metals or metalloids, they have the properties midway of those metals and non-metals. So napapagitnaan sila. So there's a zigzag here. And that zigzag shows the semi-metals, the location of your semi-metals. So let's look into the different properties or characteristics ng ating mga classification of elements. So let's start with metal. So metals are typically solid with high melting points and high density and have a bright metallic luster. So for example, this is gold leaf and this one is copper. Okay? So this one is gold AU and this one is copper CU. So metals are also good conductors of heat and electricity, especially copper. We all know that our electrical wirings are made up of copper. So if metals can be hammered into thin sheets, it is said to be malleable. For example, is your gold. So, 'di ba, meron tayong nakikita na bloke-bloke ng gold. So, pwede natin siyang i-hammer, pitpitin, so it can form thin sheets. But if your metal can be drawn into fine wire, so like for example, copper, pwede natin siyang gawing mga wiring. So we call it ductile. So your copper is ductile. Okay? So that is for properties of your metal. On on the other hand naman, non-metals naman natin, they have very low melting points, very low densities, and have a dull appearance. So for example, ang classic example natin dito sa loob ng nitong cylinder na to, glass cylinder, this is oxygen. So O2. This yellow particles here, this is your sulfur. Or S. S lang yan. S. Sulfur. S. So nonmetals are poor conductors of heat and electricity. Uh, Unlike your metals, your nonmetals are not malleable or ductile, pero it will be crushed into a powder when hammered. For example, you have your sulfur or this is called azufre. So ito yung nakikita nyo in your volcanoes. So if you hammer this one, this will become powder. Okay? And 11 nonmetals occur naturally in gaseous state. So ano yung mga elements na yon? So you have nitrogen, oxygen, chlorine, bromine, iodine, and then we have your noble gases, helium, neon, argon, krypton, xenon, radon. So yan ang mga yan. These are all gaseous forms. These are nonmetals that are also gaseous. So just to summarize, yung comparison between the two, the metals and nonmetals. So in the physical state, metals are solid, generally solid, with the exception of two, or actually one. Yung mercury natin, Hg, is liquid in room temperature. So nonmetals are usually solid or gas. Appearance, there's a luster, so very bright yung surface. Pero nonmetals natin are dull. Pliability, so malleable, pwedeng gawing mga thin sheets. Pwede ring gawing wiring, so ductile ang ating metals. Our nonmetals are very brittle. Pag pinukpok mo, nagiging powder. In terms of conductivity, it conducts heat and electricity, but our nonmetals are non-conductor. Density, so usually high ang metals, low naman sa non-metals. Also with melting point, usually high, and then usually low for non-metals. Chemical reactivity, your metals will react with non-metals, and your non-metals naman will, parang reverse lang din siya, will also react with metals and itself. So, non-metals. So, ito pala, there's another, so may mga exemption kasi din yan. So, yung mercury, na nabanggit ko na kanina is solid, liquid siya in room temperature. Tapos yung bromine ay pwede rin siyang, aside from being a gas, ay pwede rin siyang maging liquid. So that is for the comparison of the two metals and non-metals. So now let's look into the periodic table. So sabi nga natin, each element is assigned a name, a symbol. So may ina-assign din tayo kasing number to it. So each element is assigned a number to identify it. It's called the atomic number. So this one is the number above the symbol. For example, atomic number 1 is hydrogen. Atomic number 2 is helium, and so on. For example, atomic number 92, that is uranium, the one that is used for nuclear bomb. Okay? So the elements are arranged by atomic number on a periodic table. So increasing number of atomic number. Parang ganito siya. So we'll start with 1, 2, 3, 4, 5, hanggang 8. Then this is so on. So increasing siya. Ito kasi, itong si hydrogen dapat nandito siya. Nandito siya. So siya yung tanging non-metal na nasa left side of the periodic table. Pero hindi siya metal. That is a gas. Okay, so according to the legend, our hydrogen is gaseous. Okay? So again, this is the location of your metals, non-metals, and metalloids. So everything to the left is your metal, exemption is hydrogen, that is a non-metal. Sa right natin ay yung mga naka-yellow, these are your non-metals. And then somewhere in the middle, this is your metalloid or semi-metals. So uulitin ko lang, metals are on the left side of the periodic table, non-metals on the right, and the semi-metals are in between this. Parang there's a stairway dyan. Yan. So yung nahagip ng stairway, that is your semi-metals. So in this slide naman, ulitin ko lang yung sinabi ko na there are physical states of elements at the room temperature. So yung ating naka-yellow dyan is gases. So yan, yung ating mga noble gases, nitrogen, oxygen, chlorine, and hydrogen. Then liquids natin ay bromine and mercury, and the rest are solid. So as a connection in chemistry, so we are still looking for other elements. So for example, itong element 104 is already named. But before that kasi, ay binibigyan muna siya ng temporary na name. So scientists continue to discover new, heavier element beyond the current periodic table. And sometimes may disagreement na nag-arise over the naming of the few elements. Because if you are the one lucky to name the element, di okay. Pero kasi pinagtatalunan din yan or pinagdedebatehan lang din yan kung alin talaga dapat yung ipapangalan. So, the IUPAC comes in and it assigns the name to the new elements. So, until the IUPAC assigns a name, the elements are named using Latin prefixes followed by the suffix IUM. Diba? We all know that our elements will end up in IUM. Ium. Diba? So, temporarily, si IUPAC, nagbibigay muna siya ng temporary name dun sa element. For example, element 104 is unilquadium. So, bakit siya naging unilquadium? Yung mga words kasi dito, these are derived from Latin. So, for example, un means one, nil is zero in Latin, and then quad, diba? Quadrangle, quadrilateral. So, when you have a prefix na quad, it means 4. So, the unil quad dyan, it means 104 or 104. Okay? So, ganyan po ang pagpapangalan ng temporarily sa ating mga elements. Hanggat wala pang pangalan yung element, ganyan po siya papangalanan. Okay? So, that is how you will name your elements. Now, for compounds naman, kasi elements yung kanina pinag-uusapan natin. Paano naman yung mga compounds? So, when you say compounds, these are combination of one or more elements. So, in this particular slides, we will try to calculate the number of atoms for each element in a compound given a chemical formula, and we will apply the law of definite proportion or composition to a compound. Okay. So may isang possibility kasi sa dito sa ating slide na to, yung law of definite composition or law of definite proportion, other term is proportion. So I was not able to put his picture here, but the name is Joseph Louis Proust. Proust. So Proust. So this is in the late 1700s. So ang naging experiment kasi niya ay he analyzed copper carbonate. So copper carbonate. So lagi niyang ini-experiment ito, and no matter how we prepare this compound, the copper carbonate, ang naging findings niya or result niya ay yung individual elements copper, carbon, and oxygen, they are always present in a particular proportion. So may percent lagi sila na may laging parehas yung percentage na na-arrive niya. Okay? So based on this paulit-ulit na experiment, he was able to to state that yung compounds will always have the same element in a constant proportion by mass. So itong binanggit niyang sentence na yan, this latter became the law of definite composition or proportion. So again, the law of definite proportion or composition states that a compound always have the same elements in a constant proportion by mass. So in terms of percentage, laging pare-parehas. For example, yung water, diba, we all know that is H2O. So if we will compute the percentage composition, so we will do this in latter discussions pa natin, yung H is always 11.2%, at yung hydrogens natin, rather, the oxygen is 88.8% by mass. So no matter what is its source. For example, itong a drop of water in your leaf, yung glass of water, etong water galing sa lake, these are all made up of H2O, and lahat ng mga yan ay pare-parehas lang na 11.2 and 88.8% oxygen. Okay? So, kahit anong source ninyo, pare-parehas na water yan at pare-parehas ang composition nila in terms of percentage. Okay? So if you really want to bakit naging 11.2 and 88.8 siya, so we can actually compute for the percentage composition of H and then percentage composition of oxygen. But before that, we will start with the molecular mass or molar mass. So ano ba ang formula, ang atomic mass ng oxygen? That is 16. And then your hydrogen is 1.008. So para makuha mo yung molar mass ng water, you just multiply 2 times 1.008 plus the 16. So this one is 2.016 plus 16.00. So you have 18.016 grams. So this is the total mass ng water. And paano natin ba mako-compute yung percentage? So you just compute the contribution ng particular na element over the total. So for example, hydrogen, the two hydrogens there, the total mass nun is 2.016 grams. And the total mass of your water is 18.016 grams. Tapos kukunin natin siya times 100%. For oxygen naman, you have here 16 kasi 16 grams yung contribution niya ng oxygen. And the total mass of your water is 18.016, then times 100. So grab your calculator and let's see if tama ba na 11.2 yung ating 11.2% yung ating mako-compute. So if we will compute that, 2.016 divided by 18.016 times 100. So that is, 11.19% or just 11.2%. And then for oxygen naman, 16 divided by 18.016 times 100. So you have 88.80% or just 88.8%. So tama yung ating calculation na 11.2% ang contribution ni hydrogen and then 88.8% naman ang contribution ni oxygen. So that is the interpretation for the law of definite proportion or composition. Okay, so we will be doing a lot of this later on. Okay? Now, let's interpret your chemical formulas. So, yun nga, ang chemical formula ng water is H2O. Diba? So, ang tawag natin dun sa a unit of matter composed of two or more non-metal atoms is a molecule. So, for example nga, water, H2O. You know, H and oxygen, these are both non-metals. So, yung na-create nyo na H2O, yung isang, yun, di ba yung parang, asan yung drawing ng H2O here, this one. The oxygen here is the red one, and itong white balls here, these are your two hydrogens. So, this one is called a molecule. So, it's called a molecule if it's non-metal atoms bonded together. Okay? So, a unit of matter composed of two or more non-metal atoms is called a molecule. Now, you usually express our compounds natin in terms of chemical formula. So, a chemical formula is an expression of the number of atoms of each element in a compound. For example, sulfuric acid. So, the chemical formula for sulfuric acid is H2SO4. So, anong ibig sabihin ng H2SO4 na yon? So, if this is the drawing or the model for sulfuric acid, so you have two hydrogens, you have one sulfur, and then you have 4 atoms of oxygen. So, again, yung nakikita nyo ditong white, this is hydrogen. Yung nakikita nyo red is oxygen, commonly, and then the yellow one here is your sulfur. So, we have one sulfur, nasa gitna. We have how many oxygens? 1, 2, 3, 4. So, 4. And then how many hydrogens are there? 1 and 2. So, that is an expression of kung ilan yung atom sa isang compound. So, kapag tinanong kayo, ilan lahat yung atom na meron doon sa isang molecule ng inyong sulfuric acid, so you just add the number. So, you have 2 plus 1 plus 4. So, itong isang molecule ng ating sulfuric acid, meron siyang 7 atoms. 7 atoms made up of 3 elements, hydrogen, sulfur, and oxygen. So ano pa, para ma-specify ninyo, there are 2 atoms of hydrogen, 1 sulfur atom, and then 4 atoms of oxygen. Okay? So, may mga rules kasi in naming or may mga rules kasi na dapat masunod para dun sa pagbibigay o pagni-name o pag-write ng chemical formula. For example, yun nga, naglalagay kasi tayo ng subscript. So we always put a subscript. The subscript is the small number after the symbol. Correct? C10. So ibig sabihin yan ay there's 10 carbon atoms in your structure. So if there's only one atom in a certain type of atom, the number 1 is not used. So you don't write C1. So hindi na nilalagay yung 1. You just write it C. It's understood that if there's no number there, then you have 1 carbon. So a molecule, ito, bigay tayo ng example. A molecule of vitamin B3 ay may 6 carbon atoms, 6 hydrogen atoms, 2 nitrogen atoms, and 1 oxygen atom. So what is the chemical formula? So para masagot nyo to, dapat medyo familiar kayo with the symbolism of your element. So carbon is C, hydrogen is H, nitrogen is N, and then oxygen is O. So you just copy those. So C, H, N, O. So you just put how many carbons there are? 6. How many hydrogen atoms? There's also 6. Nitrogen atoms will be 2 and then just 1 oxygen. So no need to write 1 here. So the answer is C6, H6, N2O. So may tanong ba na pwede po ba magkapalit? So ako kasi kapag may carbon and hydrogens na kasama dun sa formula, chemical formula, I usually put the carbon in hydrogen. Carbon first and then hydrogen. And then itong mga other elements can be iba-iba na yung order nila. So just as long that you have the same or the correct number of atoms, that's okay. The arrangement is not that important. Okay? So that's how we write chemical formulas. But sometimes you need to interpret the chemical formula. Like for example, some chemical formulas that use parentheses. So to clarify the atomic composition. For example, this one is ethylene glycol. This is a component of antifreeze. So ito yung nilalagay sa mga radiator para hindi siya mag-freeze, di ba? Kaya siya antifreeze. So it has a chemical formula of C2H4OH, then is OH parenthesis 2. So it means paano natin siya interpret na ganyan? So the C2H4OH2 means that you have 2 carbons of atom, 4 hydrogen atoms, and then eto paano to? Ibig sabihin ng OH dyan, you have 2 units of OH. So dun sa loob kasi ng OH, may isang oxygen atom at may isang hydrogen. Pero kung tatanungin mo kasi ilan talaga lahat, so dapat ay masabi mo na you have 2 carbon atoms, dalawang carbon, ilan ang hydrogen. So originally you have 4 here and then may dadagdag kang dalawa. So you have 2 plus 4, so you have 6. So a total of 6 hydrogen atoms and then ilan ang oxygen? You have 2 oxygen atoms. So if you will be asked how many atoms are there, total number of atoms in ethylene glycol, so you should answer it should be 10. So 2 plus 6 plus 2, then you have 10 atoms. Okay? So that is how you interpret your chemical formula. If you have encountered a if you have encountered a chemical formula with parentheses. So, yung 2 dito, parang dinidistribute mo siya. O, isa lang siya sa loob, pero dahil may dalawa, so you have 2 oxygen. You have 1 hydrogen here inside, but since there's a 2 subscript 2 here, so that means you have 2H and then add the H here. So you have 4 plus 2, you have 6. So that is how you should interpret your chemical formula. Okay. Ngayon, ay paano ba natin malalaman kung paano natin malalaman yung physical and chemical properties ng isang substance? So, pag sinabi natin physical property, ito yung characteristic of a pure substance that we can observe without changing its composition. So, you just observe it. For example, if you're given a sample of sulfur, yung kulay yellow na powder kanina na pinakita ko sa inyo. So, sulfur is color yellow, it's brittle. So, anything that you can describe dun sa ating sample without changing its composition, then that is a physical property. That includes the appearance, yung color, ano ba siya, crystalline ba siya, anong appearance niya. So, yung melting and boiling points, density, heat, electrical conductivity, solubility, and physical state. So, these are all physical properties. But, if mayroon na siyang chemical reaction with another substance, then that is a chemical property. For example, yung sodium, if you know sodium, yan, ito, magbigay tayo ng example. Diretso na. So, sodium and chlorine. So, yung sodium, ito, physical property niya, ayan, nakita natin, it's a metal, it's shiny, mukha siyang soft metal siya. Then, ano pa ba? Yun, soft metal. Yung chlorine gas ay gas siya, yellowish or greenish, yellow-green yung color niya. So, ganun ang physical properties nila. Ngayon, kapag nag-react na sila with each other, then that's the time na masasabi na natin yung chemical property nila. So, sodium metal, when it reacts with chlorine, wala lang akong video dito. If you can search in YouTube, if you mix sodium and chlorine, it results into a violent reaction. As in talaga may sparks and everything. So, when sodium and chlorine kasi ay nag-react sila with each other, you will form another substance that is called your NaCl or your table salt. So, as you can see, yung nag-iba na yung property. Kasi naiba na siya from elements to compound na siya. So, ito palang sodium and chlorine ay ito yung mga toxic elements to mga to, very dangerous. Pero yung table salt, ito yung na-enjoy natin para bigyan ng lasa yung mga pagkain natin. So, sodium metal, Na, reacts with chlorine gas to produce sodium chloride or your NaCl. Okay? So, makikita lang natin yung chemical property ng isang bagay if it reacts with another substance. And since we are now discussing chemical and physical properties, let's also discuss physical and chemical changes. So again, yung physical change naman, take note, is change. A physical change is a change where the chemical composition of the sample does not change. For example, if I will just tear a paper, pilasin ko yung papel, so no matter gaano ko kadaming beses pilasin yung papel, the action na action ko na pagpipilas, it doesn't change the composition of the or the paper. So that means it's a physical change. So sa physical change, it just involves the difference or the change in the physical state. For example, uh, yung ating ice, 'di ba? Pag iniwan ko siya in the kitchen, tas naiinitan siya, naaarawan siya, so it will just change the state of matter from solid to liquid. Or pwede namang shape. Tulad nun, yung papel, pinilas ko ng pinilas, kahit pinilas ko siya ng pinasin, it doesn't change the chemical composition. It's still paper, but in shredded form lang siya. Yung chemical change, on the other hand, this is a chemical reaction. So, ito yung na-observe nyo if there's a chemical reaction. And for sure, nag-iiba na yung composition. For example, if I decide to sunugin yung paper, so from paper, cellulose, iba na yung magiging composition niya after burning. It will become ash. So, the composition of the sample change during a chemical change. So, parang ganito. Ito po yung sinasabi ko kanina. Ito naman yung reaction. This is a reaction of your sodium metal in water. So as you can see, nagkakaroon siya ng violent reaction with water. Okay. So ano ba yung mga evidences para magkaroon, ano yung mga evidences to show na may chemical change na nangyari? So one example is release of gases or bubbling. So for example, this is iron in hydrochloric acid or zinc in hydrochloric acid. As you can see, there's a vigorous bubbling. Okay, so may vigorous bubbling. And ano yung na-produce na gas dyan? That is hydrogen gas. There's also light or release of heat energy. For example, ito, yung sodium metal, when you put it in water, it will result to sparks. So, yun. Nakikita nyo, may sparks siya dyan and the color of the flame is color red. And another evidence for chemical change is itong may permanent color change. So, as you can see, something is something dropped in this test tube with containing a particular reagent. Both of them are colorless. But when this liquid was dropped in the test tube, as you can see, there's a change in the color. It became yellow. So this one is an evidence that there's a chemical reaction happening. So there's a chemical change happening in your sample, in your substance. So ito siya. There's another picture lang to. This is not animated. So yan. So there's fire or flames. There's sparks. And then there's bubbling. And ito, there's a change in color. Okay. Bibilisan na lang natin kasi madami-dami pa ito. So, malapit na naman tayong matapos. So, may mga laws kasi tayo na ma-encounter as we go along. So, the first law is the law of conservation of mass. So, a side story for that, in our previous lecture videos kasi, I mentioned Antoine Lavoisier, Lavoisier. So, is a French word kasi, a French personality, French chemist kasi siya. So, siya yung tinatawag natin na father of the modern chemistry. So, kaka-experiment niya. So, he also found a principle. So, meron siyang state na sabi niya, he found out that whenever there's a chemical reaction before and after, the mass is still the same. So, sabi niya din, Antoine Lavoisier found that the mass of reactants before a chemical change was always equal to the mass of products after a chemical change. So this was his statement, and later on, this became the law of conservation of mass. So sabi din dito, the law of conservation of mass is matter is neither created nor destroyed in a chemical reaction. Okay? So 'di ba, pag sinabi nating matter, ang lagi nating pinapasok sa isip natin ay ito ay atoms. So yung mga atoms ng ating mga substances, they just rearrange themselves. So you don't create your atoms. So the atoms here are not created nor destroyed, but they just rearrange to form another substance. For example, diba? Na and then Cl. So if this will react, these two will react, this will form NaCl. So yung atoms ng sodium mo, dalawa, magre-react siya dun sa ah, isang molecule ng ating Cl2, so it will produce NaCl or your salt. So ano ba yung mga ibang interpretation dun sa law of conservation of mass? So again, the total mass of the reactants will be equal to the product. So kapag nag-discuss kasi tayo ng chemical reaction, this part here is called your reactants. And this part here is your products. When say reactants, these are your starting materials. Your products will be the resulting substances formed after a chemical reaction. Number two is the mass before the reaction is just the same after the reaction. So matter is neither created nor destroyed, and no change in mass takes place. Okay, so that's the different interpretation for the law of conservation of mass. For example, if 1 gram ng hydrogen combines with 8 grams of oxygen, di ba, we know that hydrogen reacts with oxygen to form your water. So for example, you have 1 gram here, then you combine it with 8 grams of oxygen, how many grams of water will be produced? So you will produce 9 grams. So 9 grams of water is produced. So 3 grams of hydrogen plus 24 grams of oxygen. So you have 27 grams of water. So paano naman kung baliktad? If you start with water, so if you start with water and you want to break it down to oxygen and hydrogen, so sabi dito, if 50 grams of water, 50 grams of water decomposed to produce 45 grams of oxygen, ilang grams yung inyong hydrogen? So how many grams of hydrogen are produced? So you just simply subtract 50 grams, subtract 45 grams for 50. So 50 minus 45, you have 5 grams of hydrogen that is produced in the decomposition of water. So, meron kang 5 grams ng hydrogen na na-produce. Now, for the discussion of potential and kinetic energy, so kasi isa din sa mahalaga na concept na pag-usapan natin dito is yung energy. So, oftentimes maririnig nyo ako na the energy of the reaction is like this, ganyan. So, kailangan medyo may alam din kayo sa sa concept ng energy. So, nung elementary days kasi tayo, ang lagi natin binabanggit, energy is the ability to do work. So, 'di ba? Kapag may energy ka, you can do work. And we have two types of energy, the potential and the kinetic energy. So, this one is already discussed in elementary days. So, when say potential energy, this is abbreviated as PE. This is the stored energy. So, ito yung stored energy. Ito yung energy within. Okay? Then, ito ay nanggagaling saan? Doon sa position or composition ng isang bagay. In physics kasi, kunwari, may isang rock sa taas ng mountain. So, yung potential energy niya is based on the height niya from the ground. So, from the ground, pataas doon kung sa position niya, that's the potential energy. But in chemistry kasi, ang potential energy ay nanggagaling doon sa composition. So, when say composition, ito yung tinatanong natin, ano yung chemical formula niya. So, ilan bang carbon, ilang hydrogens, ilang ganon. So, may energy kasing nakastore doon sa particular na substance na yon. Now, or on the other hand, your kinetic energy or KE, it is the energy of the matter that as a result of its motion. Diba? Sabi nga natin, sa tatlong states of matter, solid, liquid, and gas, ang pinakamataas ng energy doon ay yung gases. Bakit? Kasi yung gases ang pinaka-mobile o siya yung pinaka-laging gumagalaw. So, kinetic energy is kinetic energy is associated with motion. So, if you're moving, mas mataas ang energy mo, di ba? Parang bata. Pag mataas ang energy niyan, hyper yan. Malikot yan. So, ganun ang analogy in kinetic energy of your particles. So, energy can be converted between two types. So, ito yung sinasabi natin na pwede natin siyang i-transform. So, pwede natin i-transform yung energy from one type to another. So, yung potential energy, we can convert that to kinetic energy. For example, a boulder or just a rock. So, may malaking bato sa taas ng mountain, it has a potential energy. But if you push down the mountain, the potential energy is converted to kinetic energy. So, parang example, another example is like this. If you have a cannonball, naka-rest pa yung ball, yung iron ball dun sa loob ng cannon. So, may potential energy yan. Okay? Then, according to physics, this is physics, kapag na-reach na yung maximum height, so nandoon din yung potential energy at maximum. And the kinetic energy is also at minimum. Then, habang bumababa na yung bola, the kinetic energy increases. Okay? So this is physics, but you don't need the ano naman, the intense explanation for this. So, let's just relate kinetic energy, temperature, and physical state. So sabi natin dito, yung solid kasi 'di ba kung natatandaan niyo dun sa unang discussion pa natin, tightly packed nung ating mga particles. So they cannot move. So if they cannot move, then yung kanilang kinetic energy is very low. Okay? Yung liquids naman, they can move a little. So medyo nag-i-increase na yung kinetic energy. But for gases, ito talaga yung very mobile. So kung saan-saan sila nakakarating. So napakalaki ng space na pwede nilang i-travel. So napakataas din ng kinetic energy nila. So sabi dito, all substances have kinetic energy regardless of their physical state. So sa tatlong states of matter nga natin, solids have the lowest kinetic energy and the gases have the greatest kinetic energy. Again, we associate kinetic energy with the movement or motion. So if you recall our solids, di ba, very tightly packed together yung kanilang particles, so magkakatabi sila, they cannot move. Pero nakaka-move naman sila ng very slight. Pero yung ating gases kasi ay magkakalayo sila, so may tendency silang mag-travel in every direction. So gases have greatest kinetic energy. Now, paano natin i-associate naman yung kinetic energy with the temperature? So if you increase the temperature of the substance, its kinetic energy increases. 'Di ba? Ito yung sinasabi natin na from solid to liquid to gas, if you increase the energy, if you add energy to the solid, eventually it will become liquid. If you add more energy to your liquid state, eventually mag-evaporate siya, evaporate, so tataas yung kinetic energy ng inyong gases. So, nangyayari lang yun kapag nag-change tayo ng temperature. Again, di ba? From solid to liquid, this is melting. And melting happens if you increase the temperature. Liquid to gas happens yung evaporation kapag tinaasan mo din yung temperature. So, yung temperature na yon is kinetic energy. So, as you increase the temperature of the substance, its kinetic energy increases. So, yung solid natin, di ba, magkakatabi yung mga particles nila. Yung sa liquid, medyo magkakalayo ng konti lang. Pero yung gases talagang magkakalayo sila. And may tendency silang mag-travel in every direction. So, may tendency din silang mag-bump into each other. So, just to summarize this third statement, if you increase the temperature, you are increasing the kinetic energy, and this is also manifested in more motion. So, more movement happens. Okay? So, yun ang ating discussion on energy. From our previous slide kasi, di ba, meron tayong tinatawag na law of conservation of mass. We also have the law of conservation of energy. So, just like matter, energy cannot be created nor destroyed, but it can be converted or transformed from one form to another. And this is the statement of the law of conservation of energy. So, there are 6 forms of energy: heat, light, chemical, electrical, mechanical, nuclear, and so on. Pero these are the 6 basic forms of energy natin. So how do we apply that law of conservation of energy? For example, let's now let's now use the concept of physical and chemical change. So, 'di ba? In physical change, 'di ba? You are just involving the change in the state of matter. For example, liquid to gas. Liquid to gas, 'di ba? Liquid to gas 'yan. Now, if you want to if you want to change your liquid to gas, you need to increase the temperature, right? So ini-increase natin yung temperature. Ngayon, will solve to the increase in the kinetic energy of your particles here, di ba? Ito, magkakalapit pa yung mga water molecules natin. Pag tinaas ang temperature, magiging liquid, magiging gas yan. So, makikita nyo, nagkakalayo-layo na yung kanilang mga molecules. So, tumataas na dito yung kinetic energy. But in order to do that, you need to supply energy. So, you need to supply energy. So, ito, yung tinatawag natin 540 calories. So, calories is the measure of energy. So, you need to insert or you need to add 540 calories of heat in your 1 gram of water. So, if you have 1 gram of water, that will change to gaseous form if your temperature is 100 degrees Celsius and you supplied 540 calories of heat. So from your 1 gram of water, it will become 1 gram of steam. So yung energy dito is absorbed. Na-absorb siya. Na-absorb siya into the water para maging ma-transform siya from liquid to gas. But if you want to do the reverse process from gas to liquid, the same amount of energy you supplied or you absorbed, dapat mo siyang i-release. So, kailangan mo siyang i-release. So, 1 gram of steam here or gas, kailangan at the same temperature, 100 degrees Celsius, or dapat nga pas bababa ito, ay matatransform siya into 1 gram of water if you release the same amount of energy that was absorbed kanina. Okay? So 1 gram of steam at 100 degrees Celsius will become 1 gram of water with the release of 540 calories. So, sabi nga ng law of conservation of energy, dapat yung energy na na-absorb mo ay dapat equal lang din sa heat or the heat energy na i-release mo if you transform from one state to another. That is for physical change pa lang. What if you have a chemical change? So when say chemical change, you also add energy. You also add energy, but there's a chemical change happening. Ibig sabihin, ito na yung pwedeng may bubbling or formation of gas or may formation of light or ano pa ba yon? Yung ating uh, ito. There's also yung mga evidences, formation of gas or release of gases or bubbles. There's light release or heat energy and color change. So for example, ang example natin diyan ay yung water, 'di ba? H2O. You want to break this down into hydrogen gas and oxygen gas. So this one is a chemical change. So in order to do this, you need to supply energy then. So you will supply energy. So in this form, yung separation of hydrogen and oxygen from water, that is called electrolysis. So nabanggit ko to kanina, when say electrolysis, you are adding electricity. You are using electricity to separate the hydrogen and the oxygen. So your water should absorb that energy, that electrical energy to break down your to break your water into hydrogen and oxygen gas. Okay? Now, yung energy na yun is absorbed by the water. Now, if you want to do the reverse, you'll start with the elements. Ito, diba? These are elements, the hydrogen gas and oxygen. You want to form your water. So your hydrogen and oxygen should react with each other and your reaction with each other will result to the release of energy. Okay? So, pag nagpo-form kayo ng water, so nagpo-form yung water from hydrogen gas and oxygen gas, there's also release of energy in the form of heat. So, according again to law of conservation of energy, dapat yung electrical energy that was absorbed by water will also be equal to the heat energy released if you are trying to combine hydrogen and oxygen gas together to form your water. Yung una kasi is, this is the breakdown This is the breakdown of water. This one naman is the formation of water. So there's a chemical reaction involved in these two scenarios. So there's a chemical change. So again, in a chemical change, energy is transformed from one form to another. Okay? And ang ating kasing law of conservation of energy ay ito ay ang isang scientist dito na kilalang-kilala is no other than Albert Einstein. And Albert Einstein was able to integrate yung yung law of conservation of atomic energy into one single statement. So ito yung tinatawag natin na law of conservation of mass and energy. And people relate the mass and energy with this famous formula natin na EMC squared. So sabi niya, just matter. Energy is equal to matter times the speed of light squared. So that is according to the theory of relativity. So according to Einstein, your mass and energy can be interchanged. So now there's a combination of the two laws natin kanina, the law of mass, law of conservation of mass according to uh, Lavoisier, tapos yung isa is law of conservation of energy. So we can combine the two as the law of conservation of mass and energy. And it states that the total mass and energy of the universe should always be constant. When say constant, it should not change. So it should not change. Okay? So, yeah. So natakal na natin lahat ng ating mga kailangan sabihin. So, to sum up the whole chapter, we're able to discuss the three states of matter into the three physical states of matter: solid, liquid, and gases. We acknowledge that there are other states of matter, but we will focus more on these three basic states of matter. So substances can be converted into three states. So you have here the phase changes. So what happens? And what you call the process wherein you convert solid to liquid, liquid to gas to liquid, gas to liquid to solid, and solid to gas, and gas to solid. So there's a particular name for that. So substances can be mixtures or pure substances. When say mixture, these are combination of two or more substances that can be physically separated. Your pure substances can be uh, made up of your atoms, your elements and compounds. Yung elements kasi cannot be further broken down, and then yung compounds nyo kasi can be broken down into the constituent elements sila through the means of chemical means. Okay, so that's the point there. The substances can be mixtures or pure substances. So nabanggit ko na, a pure substance can either be a compound or element. Yung elements natin in the periodic table, they are arranged. So each element has a name. So there's a name for each element and a one or a two-letter symbol. We also classified your elements as either metals, non-metals, or semi-metals, or you also call this your metalloids. And lastly, we're able to discuss the physical and chemical change. So again, physical change is just a change in the physical state or the shape. If you tear your paper, nothing happens. Nothing changes in the composition of your paper. You're just shredding it. Diba? But if you have a chemical change, this is the time you have a change in the chemical composition of a substance. If you burn your paper, then after the reaction, the chemical composition of the ash is different from the starting material mo, which is your paper. And lastly, we're able to discuss that both mass and energy are conserved in chemical and physical changes. Hence, we have the law of conservation of mass and energy. So that ends my discussion for chapter 3, matter, and energy. Thank you very much for listening.